The Breathing Soil, a PQNK dialogue on humidity and soil structure. PQNK, the Pristine Organic Farming System. Importance of relative humidity and crop production in PQNK farming. Based on the hydraulic architecture of the PQNK raised bed system, relative humidity, RH, is not merely an external weather condition but a direct result and key indicator of the engineered root zone environment. Its importance is understood through its intimate connection to soil moisture and plant transpiration. The feedback loop of plant transpiration. In the PQNK system, the porous, aggregated structure of the raised bed acts as a moisture battery. It stores capillary water in the micropores while macropores ensure free drainage. A vigorously growing plant in this ideal environment freely transpires, releasing water vapor into the immediate canopy atmosphere. This creates a positive feedback loop. Optimal soil moisture, vigorous plant, high transpiration, elevated local RH around canopy. This elevated local RH, particularly during early morning hours, is a bioindicator of a fully functional system. It shows that the plant is not under hydraulic stress and is actively collaborating with the soil ecosystem to regulate its microclimate. The hydraulic bridge between soil and atmosphere. The PQNK raised bed is engineered to wick moisture upwards via capillary action, countering gravity. This constant supply of moisture to the root zone is matched by the plant's transpiration, which pulls this water up and releases it as vapor. Therefore, the RH around the crop canopy is a real-time measure of the efficiency of this hydraulic bridge. If the RH is consistently low at the canopy level, it signals a break in this bridge, likely due to poor soil structure, lack of aggregation, or compromised microbial activity that sustains this wicking potential. A managed parameter, not an imposed one. Conventional farming sees RH as an external challenge to be countered with irrigation. In PQNK, the raised bed system is designed to engineer and moderate the RH itself. A properly constructed bed ensures that even during dry atmospheric conditions, the root zone remains hydraulically connected, allowing the plant to maintain transpiration and create its own protective humidity shield, thereby reducing abiotic stress. In summary, from the PQNK paper's lens, relative humidity is the visible breath of the living soil plant system. A healthy PQNK raised bed, with its optimal hydraulic architecture, will naturally manifest a favorable RH regime around its plants, which is a key driver of vigorous and sustained production. Does the size of soil aggregates affect crop production? What are the best soil aggregate sizes? The PQNK knowledge paper places soil aggregate size and stability at the absolute core of the system's design. It is the fundamental physical determinant of the aerobic and hydraulic architecture of the raised bed. 1. The non-negotiable role of soil aggregates. Yes, aggregate size is paramount. The PQNK raised bed is not a simple pile of soil. It is a consciously engineered structure whose functionality depends on the creation of a diverse pore space network. This network is built by soil aggregates of varying sizes. Macropores, between larger aggregates, these are the aerobic highways responsible for vital gas exchange. This is the process of O less than sub greater than 2/sub in, CO sub greater than 2/sub out. Think of it as the soil breathing. The roots need fresh oxygen, O less than sub greater than 2/sub to come in so they can stay healthy and absorb nutrients, and they need to push out the used air, carbon dioxide, CO sub greater than 2/sub so they don't suffocate. Micropores, within and between smaller aggregates, these are the hydraulic capillary reservoirs that hold water tightly against gravity, making it available for plant and microbial use. Two. The best soil aggregate sizes for the PQNK raised bed. The paper defines the ideal not as a single size, but as a spectrum of aggregation that creates the optimal balance between the aerobic and hydraulic domains. The Goldilocks zone, the crumb structure, The target is a stable crumb structure where the majority of aggregates fall within the 1 mm to 10 mm range. This specific range is critical because aggregates smaller than 1 mm, a fine powder, risk compaction, reducing aeration and stopping the soil's breath. Unstructured clods larger than 10 mm create overly large pores that can break capillary continuity and provide poor root-soil contact. The engineering specification: within this crumb structure, we aim for a mix 20 to 30% of aggregates in the 2 to 5 mm range. These are the ideal building blocks, creating stable pores that support both root penetration and capillary water movement. A diversity of other sizes between 1 mm and 10 mm, this ensures a well-connected, multi-scale pore network. (3) The ultimate quality test: stability in water. As per PQNK principles, the stability of these aggregates is more important than their dry size. The slate test is our quality control protocol. A stable PQNK aggregate, bound by fungal hyphae and microbial glue, will hold its shape when immersed in water for a significant period. An unstable aggregate will immediately dissolve, signaling a lack of biological life and a doomed hydraulic structure that will collapse upon irrigation or rain. In summary, from the PQNK paper's lens, the best soil aggregate sizes are a stable, diverse crumb structure between 1 mm and 10 mm. This is the very material from which we engineer the PQNK raised bed. It is this specific physical architecture that creates the synergistic environment where water, air, and roots can coexist perfectly, leading to the vigorous plant production the system is known for. Any production process that inundates soil with water, disturbs soil through tillage, or leaves soil bare without organic mulch cover does not qualify as natural ecosystem science for production agriculture, PQNK, picnic.